Welcome everyone to the triple week. We will be doing 3 sections this week, but they're all kind of short. All right, so we're going to start with this video. It's kind of short as well. We are looking at exponential functions, specifically e to the x, but sort of every exponential function and kind of how do they relate with derivatives. So we're going to start with a property. And if I have any number raised to the x power and I want to take the derivative of it, so remember this is the derivative with respect to x of b to the x, where b is just some number that's not equal to these silly numbers like 0 and 1. In fact, I'm pretty sure this is for positive b. Positive b that are not equal to 1 is the technical thing right here. That's our definition of not silly numbers. It is going to actually be itself. The derivative is itself, almost. All right. It's going to be itself times the natural log of b. And we'll talk more about natural logs later on in this section, later on in this week, in future sections in chapter 2. And we'll talk about why this is something really kind of interesting. But in the meantime, we're not going to use fancy things about natural logs just yet, but your calculator can assist you. So let's use this property with example 1. All right, calculate the following. How do you take the derivative with respect to x of 2 to the x? So here b is just 2. And we want to evaluate that derivative when x is equal to 3. So remember, this notation means take the derivative first. And then at the very end, once you're done with the derivative, then you plug in 3, not the other way around. Otherwise, you're going to get, again, some more very silly stuff. So we're going to use this property that we talked about just up here. The derivative is going to be itself, 2 to the x. But then we have some other stuff, just some number. The natural log of b is the base. It'll be 2 to the x times the natural log of 2. And again, we're still plugging in 3 at the very end here. But we're almost done. This is the derivative. We found the derivative. We just used the property. The derivative of an exponential function is itself times the natural log of the base. Itself times the natural log of the base. Okay? So now that we've found the derivative, we can evaluate it when x is equal to 3 to get 2 cubed times the natural log of 2, which is 8 ln 2. And you can type this into a calculator and get an approximation, or you can leave this as a final answer. If you did type this into a calculator, what you'd get is something somewhere. On my calculator already. Give me 1 second. Moving something over here. 8 times the natural log of 2 is going to be 5.5452. All right, so you can have either answer here. Usually exact answers is better unless we're doing applications though. All right, and that's basically this section. Well, that's basically this video. Let's do a couple more though for extra practice. All right, so let's do part B. I want you to find the derivative with respect to x of 3 raised to the x power evaluated when x is equal to -1. So again, find the derivative first, and then plug in -1. We're going to use that property. Derivative of an exponential function is itself times the natural log of the base. This is going to be itself, the exponential function, 3 to the x all over again, times the natural log of the base. The base of this exponential function is 3. And then we'll have to plug in x equals -1. So we do that, we get 3 to the -1 times the natural log of 3. Remember, negative exponent means reciprocal. So we're going to take that 3 and flip it upside down to get 1/3. Natural log of 3, there's no cancellation or anything like that. The 3 over here is stuck inside of that natural log. So be very careful here. You absolutely cannot cancel. This is our final answer. And again, you could plug this into a calculator and get an approximation if you'd like. You plug this into a calculator, you should get the natural log of 3 divided by 3, which is about 0.3662. All right, that is the slope of this exponential function Exponential functions look like this. Is the slope of that exponential function right here. The slope is about 1/3. Okay. So let's do one more problem. We'll scroll down a little bit. One more problem, part C. This is a nice little problem right here. Sort of reaches into the future. The derivative with respect to x of e to the x, evaluated at x equals 0. So the derivative of an exponential function is itself times the natural log of the base. But the natural log of e, those are inverse functions of each other. The natural log of e is just 1. That's really nice. So in fact, anytime you have the derivative of an exponential function e to the x, it really is just itself. It's the other bases that cause some problems, but luckily we're barely going to even talk about the other bases in this class. So got some nice stuff here. So we just plug in x equals 0. We're going to get e to the 0. Remember, any number to the 0th power is 1. So be very careful. This is not 0, but it is 1. There we go. The slope of this exponential function when x is 0 is positive 1. That straight diagonal line. So if you want, as a final property, you can include this. The derivative with respect to x. This isn't really new. We said this at the beginning. It's just e to the x. So this is really nice right here. Just like so. All right. And that makes exponentials really nice functions, because to take the derivative, you just don't change anything, which is nice. All right. Go ahead, get started. Only a couple problems for this video, but have fun.